Right. Yeah. Okay, it seems we are recording. So I'm going to continue with the component level review of my motor drive schematic, which I've designed in my previous videos. And this is the block diagram of this motor drive which I'm building. So I'm gonna go to the schematic, and actually first I'm gonna bring up this this list. So I've exported a list of all components in the schematic, and now I'm going through every single component and double checking the footprint, checking that it's the right component by cross-referencing the product code, just bringing up the page of the component, just double checking that it's what I intended to place in the schematic, because it happens quite often that because I'm copy pasting components when I create new components, I can sometimes maybe forget some field, and maybe the component gets a wrong footprint, which would be very bad if that kind of like adds problems when the board is manufactured, and then new components have to be ordered with a different footprint. And that would be the best case. The worst case is that you get like chips that have completely wrong footprint, and then you have to redo the board. So that we want to avoid that. And for this reason, I'm going through every single component. That includes also the capacitors and the resistors. So let's get on with this and continue with J1. J1 is a USB connector, and this connector is on the schematic here. Let's see. Where is the schematic? Let's see. Come on. Maybe there is another window open that has a dialog or something that prevents this from responding. But I can't see anything. No, KiCad is not responding. Okay. Oh, now I got schema here. Let's see. There we go. Right. And this one is not responding. Oh, now it's responding. Okay, cool. So J1 is let's see, where is it connected? Where is it? No, not there. Actually, there. Yeah. It gets a little slow when I'm recording the video at the same time. Right. So this is a USB B micro, and I'm gonna open up the datasheet. I'm gonna check the footprint. Let's see. I remember that when I used this component from my library previously, I ended up having there are like two of the pins that connect to the shield, to sort of the metal part around the connector, which were slightly too tight. So it was when I tried to mount that connector, I had to literally just push it in into the holes. So I'm gonna double check the footprint that is in the datasheet, and I'm going to just double check the measurements, because I created the footprint for this connector. I think I modified a different footprint, so I had to place the holes in the footprint myself, and I could have placed it maybe slightly off. So it's these two pins that go to this shield around the connector. These two. They are the holes must be, I think they're a little bit too far apart. So this is the footprint, and let's open the same footprint in our footprint editor. Let's see. And then we have Oh, jeez, this is slow. So where is the USB connector? Okay, let's check what this is as a footprint. Okay, so it's one of the footprints that's in the default library. Let me just check this again. USB 307630E. Okay. So maybe I was wrong. Maybe this was one of the footprints that was in the default library. So let's check the measurements anyway. There, connectors USB, and then it's 30. Which one was it though? Okay. So as long as the footprint editor is open, I cannot click anything here. That was kind of unfortunate. Okay, so let's see. Maybe it's the browser. Let's close the browser. Maybe it was not the footprint editor. Let's try again. Yeah, now I can do this. USB B GCT. Okay, right. So it was this one. Okay. Let's open it in the editor. For the most part, I think that the KiCad UI is manageable, but some things I find very time consuming, like for example having to open different windows. I think it would be nice if KiCad was using panes, so that I could open like a split window and have footprint in one window and my schematic in the other window. But this is how KiCad works right now. Okay, so what measurements do we expect here? 610 is across, so from, let's change the grid first. 0.1 millimeter per grid, okay. No. Point. So half a millimeter. So this one is 650. So quite obviously the distance between these two holes is slightly off, which explains why I had to push in the connector. We're gonna move this, let's see. So we have to get the measurements right against the other pins as well. So what I have to do, let's place, oh, this is quite odd because they specify the distance from the edge there. Alright, so if I were to place this particular pad, then it has to be 0.5 there. Let's double check this. This is 0.5. This was 0.45, like, damn it, come on. Okay, we have to fix this footprint. Right, so I have to copy this footprint to my custom library. I'm gonna go ahead and do this. I'll do it through the terminal, so I'll just do like this. Let's see. I'm gonna close it. No, damn it. I shouldn't have closed that one. I'll just open the footprints that I've copied to my custom library now. It should be here. Yeah. And then I'm gonna modify this pad to, let's see, hole size 0.5. Great. And this one as well. Hole size 0.5. See, this is the reason I do this kind of reviews, because getting footprints that are slightly off is a problem. Using that default footprint, that would never work for automatic automatic component placement, because the component would just not go through the holes. I had to literally push it with my fingers really hard to make it fit. So that was not a working footprint. Let's see here. Looking at this data sheet, we have 0.5 there, and then 6/10. It's 305, 3075. That should be the position here. So minus 375, right? Am I right? Am I right or am I wrong? I think this should be right. Check here. So distance here. No, this was wrong. Wait. What kind of? No. Sorry, this was. Yeah. Let's see here. Not 75, but rather it's 330, right? So we have 6. So that'll be 305 and plus 2. Plus 0.5 divided by 2, so that will be 330. So this should be no. Okay, 610 is across, so it's 305 from the center, and then it's 0.25 to the center of the hole. No, actually, let's see. Or yes, actually it is. It is 0.25 to the center of this hole. Okay. Right, so this was 610. Yeah, so this is according to the datasheet. All right, and then we have 430 from between the edges of these two pads. 430s like that. Damn, how did they make this footprint? They really made it wrong. Okay. Anyway, these two have to be aligned. The Y position 1.9. Let's see if there is any. Actually, this should be. It would be easier if I were to place all of these pads exactly as the datasheet places them. So this means that we have to move. See if we can move the whole component. So the center point has to be there, but I don't want to move one part of the component at a time. I have to do like this. I'm going to do like this. This should place them at 0. This was a little bit off there. Let's see. Let's move this. Okay. But what about right position? Okay, I was looking at the size Y, but yeah, position Y is at 0. Okay, great, awesome. Okay. So making sure just that this one has also position 0, which I think it does. Yes, it does. Okay, and now we can place all the other pins on this footprint by looking at the measurements here. So we have 0.5 between them, and 430 there. So this has to be 3 point. Okay, this 0.25 would be from the 0.2 there, and then so this would be, let's see, 215 minus 0.25, so that would be 1.9, I guess. Let's see. Yeah, size Y 1.9. But then what is size? Let's see. What is the size of these? It looks square to me, but it doesn't say what size they are. I don't see any size here. I only see measurements across. Let's make them both 1.9. And then check this. Okay, so we have 4.3 divided by 2 minus 0.5 divided by 2, and yeah, so we need to have like 0.95 plus, yeah, let's see, 0.95 plus 0.25 would be, placement would be 1.2. position x minus 1.2. So this should give us the correct placement. Okay, and then we have the pin number 6 as well. So pin number 6 is the shield, and it connects at several positions. I chose this connector because it has the pins that go from the shield to the PCB, which makes it a very stable connector. So when you plug in the cable, you don't eventually get a connector that flies off the board, because it just has only the surface mounted pads. So this connector, having the through-hole pads that hold the connector in place, is a very good feature, which prompted me to choose this connector. So 1.4 there, and we have 480. Let's see. So we have the distance between the edges is supposed to be 8 minus 4.8, and then that divided by let's see, divided by 2, so it would be 1.4 high and 1.6 wide. That would be the size for this pad here, which is also wrong. So 1.6 wide and 1.4 high. Yeah, and obviously the position is off as well, so we'll move this. Let's see. So that would be 1.6 divided by 2 plus 0 plus 4.8 divided by 2. 3.2 would be the position of this. Let's say position x. And what is the position y? So what I do find quite odd is that they don't specify. They only specify this distance for the pins, but not for. So I think the edge is probably at 3.3. It's very small differences. It won't really matter, because this connector, even the previous footprint kind of worked for this connector. It was just not perfect. So it looks like it's. Let's see. We can double check it though. I think we can calculate the measurements here, because we have the length of the pads for the actual connections is 1.35 there, and we know that this one is 3.35. So we can kind of get the placement of the pads for the shield. So be 2 plus 1.4 divided by 2. That would be our 2.7 would be position of these pads. So 3.6 and 2.7. X is minus 3.6 and minus 2.7. This doesn't really make any sense. Is this wrong? This is definitely wrong. What did I do wrong here? Okay. So we've got 4 millimeters from the center to that edge, and minus 4.8 divided by 2, 1.6. Yeah. Could it be too? Let me just measure this. So actually, is this? Okay, yeah, that looked correct. So if I measure this 2.4 here, where would it land? So somewhere there. Okay. So it needs to move a little bit, but why did I get the wrong calculation for the position? Okay. So then we have 2.4 plus 0.8, 3.2. Okay, so that should be the position in x. So not 3.6 but 3.2. Okay, that looks good. And now we have this one, which is minus 3.2, and let's see. 2.7, right. Size x. Okay, I have to click on this. I was like, why do I see the old values there? Okay, so let's see. 3.2, and this will be minus 2.7. And this would be 1.6 and 1.4. Like that. Let's see what would make sense here. Yeah. So the connector itself is pretty much kind of ends where the hole is there. So yeah. This is kind of right, but I can just remove this graphic there. Yeah, let's place it like that. And then we have each pad. And each pad in the data sheet is 1.35 times 0.4. Let's check this. 1.4, 1.35. Number 5, 1.35. Great, and then I'll delete this one. And positioning, I think the pads are probably positioned right. It's supposed to be 130. This is so retarded. Why give like measurements for the whole like if they give measurements between the edges, you might as well give measurements between the actual pins. Okay. At least we have enough measurements to double check this. So I think it was from the middle of this one to the middle of this one is 260, which is 260 there as well, and 130 between these two. No, let me do this together. No, 130. Yeah. So at least the pitch of this pads was correct, but last thing I have to check is to make sure that they're placed correctly as well, which is going to be let's see, 3.35 minus, so the position of the pads would be this measurement here minus this measurement here divided by 2. So 3.35 minus 1.35 divided by 2, and that would give us the position. So 2.675. I'm pretty sure they're not placed correctly. Let's double check. No. So copy, and then no, really? What the hell did I do? It's not supposed to be there. Hmm. $3.35. Okay, I guess that these pads are not placed correctly either. So it's 3.35 to the edge of the pin here. Let's see. Okay, that's supposed to be, yeah, it's supposed to end pretty much there. Yeah, it was actually correctly placed. But why did I get the wrong value here? So what did I just do here? I took 335 minus 135 divided by 2. Well, it's supposed to be 335 minus half of that. So why am I not getting the right result here? What is this? Come on. What is this? So 265. Oh, I think I know what the problem was. Right. The comma. That was the problem. That was the fucking problem. KiCad doesn't accept commas. So when there was a comma there, it just truncated the number. So it was like 2. Okay. Yeah. So let's paste all of these. So they were almost correct, but not really. So I'm gonna make them correct. Okay. Great. And one thing I want to double check as well is the placement of the PCB edge. So this should be at 1.45 from the 0 line. 1.45, yeah. So this line was correct. Okay, this looks like the correct footprint. We can double check just to make sure that the pins, which I think is precisely right. Double check anyway, 335. And anything else I need to double check here? 8 between these two. Yep. And 120 is the size of this. I think the ring around the, let's see, it's 190. The ring is slightly bigger, but that doesn't make any difference. The whole size. Or actually, let's make it 0.9. And then 1.6 here. Is that really the size they want? 1.6 and 0.9. Okay. Let's see. This seems to be a little bit too small, actually. Oh no, this will work fine. This is this is to be used with when you have like manufacturing parameters from the manufacturer. This would mean that we have to support 0.15 millimeters annular rings around any drilled holes, which I know that we can support. So this is just fine. And that's true for vias as well. So any holes that are drilled through the PCB, the minimum size of the annular ring is 0.15 for the in the parameters that I use. Okay, so this is fine now, and we can just double check the pin out. Let's see. This is this the underside though? Is this the top or wait? Like no way. Without flange style. This doesn't say whether this is the underside or the top side. So this is the underside, then the pinout is correct. If it's the top side, it's not correct. I would kind of assume that this would be the bottom side because the USB connectors have to use the standard pinout. So it would be kind of odd if the KiCad footprint had a wrong pinout for the USB connector. But we have VBus on one. Let's see here. Right. What we have to check here is, so this connector has the slimmer side on the bottom there, which means that yeah, which means that pin number 1 this is the other way around. How can this be the other way around? This is so odd. Let's see. Right, so if this connector was placed on our PCB, then it would have the right pin out. But why does this say? Okay, maybe this assumes that the pins actually come out on the top side here, because then it would be correct. Which is kind of odd. Let's see. So micro B would be 1, 2, 3, 4, 5 from the wider side, which would end up 1, 2, 3, 4, 5. So that seems correct so far. So if wider side is up, it's like that, and this one gives a totally different result. Jesus, which one is correct? Come on. They're like calling them TXRX is just ridiculous. It's not TXRX, come on. It's USB, it's differential. Okay. USB standard specification. Micro B. I mean, according to this, it it would actually be wrong because we have the slimmer side down and not up, which means that okay. Although here, okay, if we just look at the footprint, then this does specify the pins, so it would be pin 1 and pin 5 there. So I'll go with the datasheet and I'll just assume that this is correct, and then I will go to the description here. Let's see. I mean, it's also questionable, of course, if the Wikipedia article is correct. It isn't always correct, but this seems to be fairly standard. And I know that the connector worked before, which is it was just fitting perfectly. So this is probably exactly as it should be. 4 is ID and 5 is G and D. 6 is the shield. Okay. Cool. Okay, let's move on. We can green this one, and we can move on to RG45. Not available. Did I forget to specify? Did I forget to specify the product number or what? I did. Although I have a product number here, which is which has the wrong name. So this comes from an older library that I had, which used MFN as manufacturer number instead of MPN as manufacturer product code. So let's see if this connector here is actually what I want. Okay, this is, yeah, cool. So this gives us the schematic of 1, 2, 3, 1, 2, 3, 4, 5, 6, 4, 5, 6. 8 is the capacitor there. 9 is okay. 9 is green. Okay, let's do like this. This would be 9 green cathode and 10 green anode. And yellow cathode is 11. And anode is 12. Okay, shield is 13, it's not here, which doesn't matter, so we can now go here. So double checking the footprint here, I'm just going to place the number as well. MPN is invisible. Great. Then yeah, RJ45 transformer. Let's see. I kind of guess that I would have to change it, but let's try first. Let's just first see if everything is correct in the default footprint. Something tells me that there will be some discrepancies between the datasheet and the KiCad footprint. Actually, regardless, I'll copy that footprint because things like Ethernet connectors and things that are kind of not really that can vary depending on the part. I don't want to have those footprints in the KiCad default library for the same reason that I don't want to have the schematic symbols in their default libraries, because I could update the default library someday, and I don't want then to have to do a new review of the components just to make sure nothing has changed. So I'm gonna copy this RJ45 into my custom library instead. And RJ45 transformer. Oh, I just realized something. I just realized something very serious. This USB, I actually forgot to update the footprint here. So I have to change the footprint. Otherwise, there is no reason to have fixed this footprint in my custom library. Let's see. So, custom. Great. And now update all the fields, which will also update the footprint on this schematic. Okay. Moving on to this one. No, actually, I'm going to open the footprint editor instead. Or let's update this component with the new footprint from the custom library. So we have that done. Footprint editor. It would be nice to have an item in the context menu where you could just right click and choose edit footprint. That would be very nice. Let's see. I'm going to load the custom version of this RJ45, and let's see if this is exactly as the datasheet says. So 1580 between these holes. obviously not correct. Let's see. Where's the 0 point, first of all? The 0 point is here on pin 1. Okay. The 0 point here is between the pins there. So it's like it's all rotated as well. So let's make this properly. Let's do this as it should be. Can we rotate all of them? Yeah, cool. That worked. Now this has to be placed like this. What I could do, okay, I'll just start by at least trying to place it close to where it should be, to avoid having to move other things around. Let's see. This would be fairly centered, I think. Like that. Okay, and now we check if this one is at 0, which it wasn't. This one as well, 0. And then 1143 is between these two, so 1143 divided by 2. 5715 is the position of these holes. Minus 5715. See, it wasn't correct. It would probably kind of like fit, but it would be a hard fit. Next is these two holes, and it's 305 between them, so we can say that these two holes have to be 305 is the position Y, and let's see, 305. And position X is 1580 divided by 2. 7.9. So this would be at 7.9. Oh, damn it. Oh, damn it. I wonder if I did the same fault again somewhere. Did I do that? Yes, I did. Was it 505? No, 571. Okay, I'm fed up with this. I have to change this. Where do I change this? Where do I change away this comma? It's probably like in my it's probably in Ubuntu language settings or something, I don't know. Oh, come on. You gotta be kidding me. Insert emoji. I have to check what this is. Like, what the hell? Can we do like... Okay, what if we do like this? Plus... malformed expression. Okay. 5,715, and that would be 5.715. Yeah. And this would be 5.715. Okay. Now, this one is supposed to be 7.9. 7.9 here as well. And this is wrong. This one is too far away. I think the calculator should automatically use a dot if I use a dot, and use a comma if I use a comma. Because this is ridiculous that it just outputs a comma there. I never use comma. I always use a dot. Let's see. So it's probably that this one is too far to the left. Where is it? 5, 7, 15. This one is 5, 7, 15. And this one is minus 7.9, 3 and 5. Oh, right. Yeah. 305. Like that. Yeah. Okay. Well, let's go ahead with the next set of pins. So the placement of these pins is, we can place 1, 3, 5 and 7 first. That would be at 8, 8, 9. So we would have 1, 3, 5 and 7, and at least the pin out is correct. 2, 4, 6, 8. And then this one will be 9, 10, 11, 12. Okay. 9, 10, 11, and 12. Okay. And now the pin number 1 is at 8, 8, 9. 89. Is it possible to edit multiple? Don't think so. No. And then it's 2.54 between the rows there, so it's going to be 889 minus 2.54, 635. So this one will be at 635. Okay, cool. So moving them a little bit down to 635. And then we have the offset from the center here. We can see that the center line is kind of cutting through this pin number 4, but it seems to me that here they're placed a little bit sort of yeah. So let's see, this 889 is supposed to be the distance from pin number 1 to pin number 8. Which means that pin number 1 should be at half of 889. So 889 divided by 2. 4, 4, 4, 5 should be the position of pin number 1 in terms of x. That seems odd. So is pin number 1 not placed? Okay. What happens if I place it at 4? Minus 4, 4, 4, 5. And that makes sense because pin number 1 here, it's cutting through a little bit through the hole there, and it's the actual hole, so not the the actual hole is the darker circle in there, cutting a little bit through the hole. Yeah, so this seems to be correct. And on pin number 2 would be position of pin number 1 plus 1.27. The distance between them is 1.27. Okay. Minus 1.27, 3,175. This will be 3,175. And pin number 3 would be minus 1.27, 1,905. And pin number 4 would be, you see they're even placed wrong. Like, this is totally wrong. They're supposed to be in between each other. This is totally wrong. 1.27, 0.635. Let's see, 0.635. And minus 1.27 minus, yeah, of course it's going to be the same, 0.635. Let's see, okay, let's see. So then it would be plus. Yeah. That would be 1.9 instead. What was it? 1.905. And number 7 would be 3,175. Let's see. And number 8 would be 4,445. Okay, and then we have, I'm gonna double check the distances as well later, but first I'm gonna place these ones. So it's 585 between them, so they're placed at 585 divided by 2. 585 divided by 2 is 2,925. I'm pretty sure that that's wrong too. 2,925. And this one is at minus 2,925. And then we have 1093 for the, let's see, for the outside holes. So 1093 divided by 2, 5,465. 5,465. And then the same for this one. 5,465. Alright, this seems to be a little bit more reasonable. So what is the distance between this one and the bin number 895. Let's see. We're probably somewhere like, we can be off from the middle a little bit. 890, yeah. Let's see what we get here. It's supposed to be, according to this, 889. Yeah, so 890 is correct. And then, let's see, and then we have 1580 across the smaller holes here. We also need to check hole diameters. 1580, yeah. And 1143, is it 1143? 1143 across these holes. Now, I'm probably not placing it in the middle, so I'm just checking if it's close enough. So it's 1143. And then the placement of the bottom holes. It's 889 plus 483. 889 plus 483. 1372. So the y coordinates of these holes have to be 1372. Adjust that as small. And then edit this one. And this one. And this one. Alright, and then we have the round 3 from the smaller holes to the okay, it seems this footprint is correct. Besides perhaps the silk screen, which we have to which we can't really see here. It doesn't really say how the silk screen is. Okay, it's 1080 from the center point. So this means that this line has to be at 1080. So 10.8. Okay. Like that. And what about the other distance here? Yeah, it's just 16.2, so 8.1. So this would be 8.1. And then minus 8.1. So something like that then. And then we just need to move this other lines here. Come on. So this would be minus 8.1. could not this one, a little bit like that. Yeah. Okay. Okay. Looking good. Looking good. So we got their J45 transformer done, and we can green light both of them. Let's see. So green there. All right. I'm going to stop this video now and take a little break, and then I'll continue with the rest of the components here. Thanks for watching.